Now example 5.2. A body of mass 2 kg initially at rest moves under the action of an applied horizontal force of 7 Newton on a table with coefficient of kinetic friction 0.1. Compute the A. Work done by the applied force in 10 seconds. B. Work done by friction in 10 seconds. C. Work done by the net force on the body in 10 seconds. D. Change in kinetic energy of the body in 10 seconds. And interpret your result. Okay. Now see here. Mass of the body is given to you. Initially it is at rest, means initial velocity, that is 0. Then applied horizontal force, that is 7 Newton. Now here we want to compute work done in these different cases in 10 seconds. So under the effect of this net force, what is the displacement of the body, that we have to first find out, because work done, that is force into displacement. So in 10 seconds, what is the displacement that we have to find? Now here friction is also there. So what is the frictional force, applied force that is given to you, and what is the net force? All this we have to calculate. Then after we have to calculate acceleration, because using that we can calculate the displacement. Okay. So force of friction, that is Fk, it is kinetic friction, so mu k into r. R, that is normal reaction, so that is mg. So mu k into mg, mu k that is given to you 0.1, m that is 2, g that we can take 10. So the answer is 2 Newton. Now 7 Newton force is applied, friction is 2 Newton. That is in the opposite direction of the applied. So here net force with which the body moves, that is F dash equal to F minus Fk, 7 minus 2, that is equal to 5 Newton. Clear? Okay. Now the acceleration, that is the net force upon mass. So net force, that is 5 Newton upon mass 2. So acceleration, that is 2.5 meter per second square. Here net force is constant 1. So acceleration is constant 1. So we can use the equation of motion with constant acceleration. So we have the equation S equal to ut plus half at square. Okay. So distance covered in 10 seconds, that is S equal to ut plus half at square, u that is 0, half, a 2.5, t 10, square of it. So distance covered, that is 125 meters. Now see here, first we want to calculate work done by the applied force. Applied force is 7 Newton. Clear? And displacement in 10 seconds, that is 125. So work done by the applied force W1, that is F into S, 7 into 125, that is 875 joule. Second, work done by friction. So again frictional force into displacement. So work done, frictional force into displacement, but frictional force that is in the opposite direction of displacement or in opposite direction of motion. So here we have to introduce negative sign. So minus Fk into S, that is minus 2 into 125, that is minus 250 joule. Third one, work done by the net force on the body in 10 seconds. So net force into displacement. So work done by the net force W3, that is F dash into S, F dash 5, S 125, so that is 625 joule. Change in kinetic energy. Change in kinetic energy, that is whatever is the final kinetic energy, because initial, that is 0. Because initially the body is at rest. So change in kinetic energy, that we can write by calculating final velocity after 10 seconds. So V equal to U plus AT, U0, A 2.5, T10, so 25. Now change in kinetic energy, that is half m V square minus half m U square, but half m U square will be 0 because U that is 0, half m that is 2, V square that is 25 square, so again it is 625 joule. So here see, work done by net force, that is equal to change in kinetic energy. So this one is as per work energy theorem. Clear?